still are going to want to watch this. We're going to take our calculators, we're going to hit the mode button. Since we were dealing with triangles today, we're going to go down, we're going to turn our calculator into degrees, just in case they've been reset since we last used them. So triangles, we are making sure we are in degrees. Marvelous. All right. And on the top of my paper, so that I can refer to it today, I'm going to write Sohcahtoa. Sohcahtoa. Because we are still using that today. So this is going to be a little bit new, but a little bit old. Okay? The perfect day after Thanksgiving break lesson. Okay. The two things we are learning about today is, this is word problems, but there's two vocabulary terms that are going to be in today's word problems, okay? One of them is angle of elevation, the other is angle of depression. So angle of elevation means that you look straight out and up. Your angle is elevated, okay? So we're going to draw an eyeball. Some of you guys are going to be better at this than others. So here's my little eyeball. There's my eyelashes. Do you guys like that? So yeah, that's pretty good, wasn't it? So we go straight out and up. So straight out and up. That is how angle of elevation works. Straight out and up. All right? Straight out and up. Okay? And then, what does the word depression make you think of? Sad. And when you're sad, do you look up all the time? No. Where do you look? Down. Okay, so for angle of depression, we're going to put the eyeball right here. Oh, I shouldn't have drawn the eyeball first. Hold on. We're going to do... Boop, boop. Eyeball is said. So for angle of depression, it is straight out and down. Do you like the little tears? You guys are like, that's what those are. They're little tears, straight out and down. All right? So angle of elevation is always straight out. You draw the picture so that the angle is straight out and up. Angle of depression, the angle is straight out and down. That's what that means, okay? Angle of elevation pictures are pretty common sense. They're pretty intuitive. Angle of depression pictures are usually not intuitive. They usually feel wrong. Does that make sense? They usually feel a little bit off. You're usually drawing the triangle where it doesn't make sense, okay? So these ones, we're going to write common sense. Common sense pictures. Over here, the picture might feel off. Okay? So straight out and down. All right, make sense so far? The two phrases, angle of elevation, angle of depression. We think we can remember the difference between those? Okay. So when you are drawing these, my recommendation is to not just draw a triangle. All of these are going to be right triangle pictures. The best thing to do is if they give you a situation and it involves a tree, it involves a boat, it involves a person, then draw that. Draw a tree, draw a boat, draw a person. The more detail you have in your picture, even if it looks terrible, and I am not a great drawer, these are my best pictures, hands down, that I've drawn in the last 10 years, okay? So even if you are not the best drawer, draw as much detail as you can because it will help you make sense of the situation, okay? If you only draw a triangle, it will be much easier for you to mess up the situation because you don't have the context in the picture. Does that make sense? You draw the boat that they talk about, then you have the context in the picture and it can help you make sense, all right? So here they said a nursery, not like a baby nursery, like a plant nursery. Nursery plants a new tree and attaches a guy wire. I don't know what that is, but I think that it is not like a person wire. I think that it has to do with something else. Because there's not a person. Because that'd be weird, right? Yeah, that makes sense. That makes sense. Okay. To help support the tree while its roots take hold. An 8-foot wire is attached to the tree and to a stake in the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. So you can see this is the part where it goes straight out and up. Straight out and up. Do you guys see that? So that's the angle of elevation. That's what they labeled in the picture. The reason that that has to be the angle drawn is because this angle up here is not straight out and up. You guys see that? So that's the reason that this is the angle that they're talking about. This is not the angle that they're talking about. The reason that it matters is because we have learned that the sides are labeled based on the angle. So the opposite side is dependent on which angle is labeled as 42. The adjacent side is labeled based on which angle is 42. That's why it matters. Okay? Find the nearest tenth of a foot, the height of the connected point. Find to the nearest tenth of a foot the height of the connected point on the tree. So they want to know what the height is from the base of the tree all the way up to right here. So what we're going to do is we're just going to start with Sohcahtoa, and we're going to label the two sides that we have. So the X and the 8, what are those two sides called? Is this adjacent? Opposite, okay. And then what's the other one? Hypotenuse. Okay. And so which trig function are we using if we have opposite and hypotenuse? Sine, that's so. So we're going to say sine of 42 degrees equals what? X over 8, opposite over hypotenuse. And so what do we do to solve for x? Multiply by 8. So 8 sine 42 equals x. And it says nearest tenth of a foot, which is how many decimal places? Just one. Okay, so what do we get? 5.4, okay. 5.4 feet. So we're going to say, now anytime we have a story problem, we're going to go ahead and just write a sentence. So I have not been making you do this all year because I said, okay, this is just math 2, we don't have to go hardcore, but this is the last unit that we're going to do in math 2, so we're going to go ahead and write sentences because it's a good habit. So how do we take this number and write it as a sentence to answer the question? Yeah. What was it called? Guy wire. Connects to the tree. .4 feet off the ground. All right. How do you guys feel? Great? Marvelous. We feel wonderful. Fantastic. Okay, doesn't this look like Luigi? Any of you guys who are like Mario fans? This looks like a dog? I think it looks like Luigi. Blurry no matter what. Tail. Zoom. Zoom. It's my zoomer does not want to zoom. The document camera said no thank you. Okay, well I tried. Alright, for this one it says, from the top of the fire tower, a forest ranger, so this is a forest, it is not Luigi. We're gonna say Luigi, forest ranger.
No one ever said that.
Okay, so at the top of a fire tower, a forest ranger sees his partner, who is Luigi, the other forest ranger, on the ground at an angle of depression of 40 degrees. So this is the part where we say the forest ranger is seeing straight out and down. Because of the way they phrased this question, it comes down. If the tower is 45 feet in height, how far is the partner from the base of the tower to the nearest tenth of a foot? So see how they up here, and then they drew this triangle. You guys see that? Okay, so what we're going to do is we are not going to use this triangle down here, because the 40 degrees is up here. We can do that, but these pictures usually don't work that way. Remember how I said they're usually a little off? Okay, it usually makes more sense to work with this triangle. It's usually going to be easier to do that. So what we're going to do is we're just going to say, well, that's the option. Okay, so typically what I would do, because angle of depression is usually this one, say if this is 45, then this over here is 45. Does that make sense? Straight down, it's the same thing. Because it's a rectangle. You guys see the rectangle? And if this across here is x, then this across here is x as well. Does that make sense? So now you guys have the option. You guys can use the triangle on top, or you can. Okay, so that's the part of this that is a little bit is that instead of using the triangle they drew, we typically end up using the triangle on top instead. That's the part. Does that make sense? Because the angle of depression is straight out and down. So the triangle you end up is this one up here. That's the part that feels off about it. Okay? So do you guys want to use top triangle or bottom triangle? Top triangle? Okay. The X. Adjacent. But he immediately said Y. Y. And then what are we going to call the 45? Opposite. Okay, so what trig function are we using? Tan. Okay. So we're going to say tan 40 degrees equals 45 over x. Okay? And then what do we do? Multiply the x, so we're getting rid of the function right now. So we have x tan 40 equals 45. And then what should we do? Okay, so divide the tan 40 over. Nearest tenth of a foot, so we're going to say point, what'd you guys get? 6 feet. Okay. Go ahead and write this in a sentence. So how should we answer the question? The partner is 53.6 feet away from base of the tower. Okay, I want you guys to notice something because we've done a few of these problems. So I'm going to write it in marker on the side. The problem that we started with the first formula, and we said tan 40 equals opposite over adjacent. And then when we finished, figured out what we were plugging into the calculator, we said 5 over tan 40. You guys see that? That's after we did the algebra to solve. What happened? Yeah, the x and the tan 40 just switched places. Do you guys see that? It's going to happen every time. If you guys have noticed, that's actually done every single time we've done one of these problems. That's been what has happened, is that these two things just switch places. So if you want to stop showing your work for that and you want to just switch the places, you are welcome to do that, okay? The only reason I show my work is because students look at my answer keys to see what they've done right or wrong, so I will keep showing my work. But if you don't want to show your work for that, you don't have to. If I were to do this answer key for calculus, I would not show my work, I would just switch them. Does that make sense? Okay, so that's a common math trick. You can just switch places with those because we know that's what happens every time. Sense? Okay. All right, so we've got that one done. Let's go ahead and do the next one. Find the shadow cast by a 10-foot lamp post when the angle of elevation of the sun is 58 degrees. What I want you guys to do is either highlight this, grab a marker, circle it, do something. This is a very common problem, and it's very common to be worded this way. So this is a good one. It's not hard, it's just the way that it's worded messes with students. So we've got a picture of it, and it's very common. So angle of elevation of the sun is 58 degrees. Length to the nearest tenth of a foot. All right, so the sun would have to be behind. You guys can see the sun is behind the lamppost. It would be making the lamppost cast a shadow. Whenever you guys can't see the shadow, I can kind of see it because it was but I'm going to go ahead and I would encourage you guys to kind of do the same. Draw the little shadow on your paper. Here's the shadow of the lamppost. So the sun would be back here, it would make the shadow right there. And then again, we have angle of elevation, so it's straight out and up. Straight out and up for angle of elevation. All right, what are the names of the two sides that we have? Opposite and adjacent. So what trig function are we using? Tan. Toa. So we've got tan 58 equals opposite over adjacent. And if we want to solve this quickly, we don't want to show all of our work because we already know the shortcut, what should we do? What do we do to solve this quickly? Yep, x equals 10 over tan 58. We can just switch these two. And so x is what? Okay, so we're going to say the length of the shadow is 6.2 feet. All right, last one. A ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find to the nearest degree the angle that the ladder makes with the wall. So this problem did not say angle of elevation, angle of depression, because that's what we're solving. We're solving the angle, so we didn't have to actually find it this time. So what are the names of the two sides they gave us? Yeah, opposite and adjacent. Okay. And so which trig function are we doing? Tan. So we've got tan x equals opposite over adjacent. And what are we going to do to solve for tan? Or solve for x, sorry. Kind of like divide by tan, but what do we actually call it? Tan minus 1, what do we actually call that? Tan inverse. So we're going to do tan inverse. So x equals tan inverse of 6 over 15. And what do we type on our calculator? Second tan 6 over 15. So x is approximately what do you guys get? 21.8 degrees. Okay, make sure you get the bubble in there. So we're going to say the ladder makes a 21.8 degree angle with the wall. Could we call that an angle of elevation? Is this an angle of elevation? No. Is this an angle of depression? No, it's neither. It's neither of them. It's not straight out and up. It's not straight out and down. So it would count as neither. That's why I'm describing it as it makes a 21.8 degree angle with the wall. Okay, that's why they didn't use that wording in the problem, because it doesn't count as either of those. Okay, so angle of elevation, angle of depression, those are not the only ways to describe an angle. Does that make sense? Did everybody hear that? You got to be careful in how you describe your angles, because those are not the only ways to describe an angle. Does that make sense? Okay, this angle up here, if this is the angle you're talking about, they are not going to say angle of elevation or angle of depression, because it is neither of those things. Does that make sense? Not straight out and up or straight out and down. It is neither of those things. Okay? All right. Go ahead and get out your assignment. You notice there's no pictures, so we're probably going to have to do a couple of those together.